Hello and welcome to this month's series because, yes, I am now only recording once a month, it seems. So, this month's series is about the department's May 2022 paper 2. Excited to get into this, but before I do, I did just want to give a shout out. Firstly, to everybody who engages with the content. I see you. I try to reply to everyone. The peeps that have found the videos useful in their preparation for their finals this last month. And people who come through with questions and corrections and tips. It's really, I love to see that kind of engagement, and I do just want to single out and highlight Sandile Dabul, who has been on a roll with the comments, and I get so excited when I see engagement like this. This one comment in particular was just like, oh my gosh, curiosity. I love to see it, and thank you once again to everyone at large who engages with the content, and I hope that for those of you who are writing your finals, your matric finals, I hope that has gone well. Wishing you love and light in your new year. Cool beans, let's get into this new paper. We are kicking off the series with question 3. Let's see what it says. In the diagram, we have a point A. Where's A? Okay, whose coordinates are 5 and 3. B, whose coordinates are 0 and a half, so just above the origin. E, whose coordinates are 6 and minus 4. And C, sorry, I skipped C, whose coordinates we don't know. We are told that those are the vertices of a trapezium, where, and we know that a trapezium has one pair of parallel sides, and we're told that in this case our pair of parallel sides is BA and CE. There isn't much else we know about trapeziums off the jump. It really is just that they have one pair of parallel sides. Right, then we're told D is the y-intercept of CE, and CD is equal to DE. In other words, D is the midpoint of this line segment CE. Okay, cool. The first thing we're asked to do is to calculate the gradient of AB. So let's see, AB, we know the coordinates of B, we know the coordinates of A, so this is just a straightforward application of the gradient formula. Okay, so pardon me, I'm just going to need to move things around on my desk, so it's just going to be a little bit. Askis. I wish there was a way for me to pause these recordings. I guess the only antidote to these problems is that I should have a better organized space up front. Anyway, so gradient, let's see. To calculate the gradient of a line, we use the formula first write it out. So the y-coordinate of B or the y-coordinate of A, doesn't matter which order you do it as long as you keep the same order at the bottom. So the difference between the y-coordinates divided by the difference between the x-coordinates. Okay, so in this case we have a half minus 3 divided by 0 minus 5. I'm definitely not in the mood to calculate that manually. Okay, and that is a half. Right, and that answer kind of looks right. Positive gradient, the diagram is kind of hinting that yes, our line has a positive gradient, so that kind of makes us feel good. Right, so now I'm just going to fill in this information that we have found out. I'm gonna need my special zoomy tool so that I can write it very tiny. So we now know that, Okay, maybe we want it a bit thinner. The gradient of AB is a half. Right. And I am now going to copy this onto the new page. Okay, so the next question says, determine the equation of CE in the form y is equal to mx plus c. So it's a straight line, and we want its equation. Okay, so what do we know? We know it is parallel to this line, so that tells us about its gradient. Okay, and then we have 1 point on the line, which is E. So we can use this information to figure out the equation of the line. So we know that the gradient, okay, we don't want it thin, we want it medium again. The gradient of CE is equal to the gradient of AB is equal to half, and that's because CE is parallel to AB, right? Okay, so therefore we know that y is equal to a half x plus c. And then we also know that when x is equal to 6, y is equal to minus 4. So we can use that to figure out c. So when x is equal to 6, y is equal to minus 4. So we have 3 plus c is equal to minus 4. So c is equal to minus 4 minus 3, which is equal to minus 7. And so we have y is equal to a half x minus 7. All right, and again, kind of the picture, kind of giving us a bit of confidence. The y-intercept, we're expecting to be below the x-axis, so to get a negative number kind of feels like, okay, maybe we're not on too lost of a path. Okay, so I'm just going to fill in the equation of the line now that we found it out. That x is like living its own life there. Be attached to your coefficient, little variable. Wow. This is what happens when I don't record for 5 million years. Okay, let's try it one more time. That's a bit better. Okay, righty-doos. Good and well. Forward we go. On to the next question. Right, next question says, calculate the coordinates of C. Oh my golly wolly. Okay, so what stands out to me is that, okay, we now know what D is, right? Because D, remember, is the y-intercept of this line, which we can figure out from this equation. So if we know the midpoint of this line, as well as one end of the segment, then we can use the midpoint formula to figure out the coordinates of C. So we know that D is, well, the coordinates of D are 0, minus 7, and that's because it's the y-intercept of CE, whose equation we have just found out. And we also know that D is the midpoint of CE, right? And so therefore the x-coordinate of C plus the x-coordinate of E divided by 2 is equal to the x-coordinate of D, and similarly the y-coordinate of C plus the y-coordinate of E over 2 is equal to the y-coordinate of D. So let's put in the values that we know. So the x-coordinate of C is what we don't know. The x-coordinate of E is 6. And the x-coordinate of D is 0. And so, in order to get 0 over here, that means the x-coordinate of C must be -6, right? If you want to do the whole times by 2 on both sides, you get 0, then you -6 on both sides, you end up with -6. Or you can just do it by inspection, right? If you want to end up with a 0, that means this guy up here must be a 0. 0 divided by 2 gives you 0. And the way to get a 0 up here is that this number should be a -6. Okay, so let's apply a similar process to find the y-coordinate of C. So y-coordinate of C plus y-coordinate of E divided by 2 must give us the y-coordinate of D. So y-coordinate of C -4 divided by 2 is -14. And not -14, what am I saying? is equal to -7, skis. Okay, time to shrink things. Just make things a bit more manageable. Right, so for this one, I'll do the full shebang. So we times by 2 on both sides, and then add 4 on both sides, so that ends up being -10. And let's just double check. So -10 minus 4 is -14 divided by 2 is indeed -7. So as such, the coordinates of C are -6, -10. And let's fill that in on our diagram. Diagram, oh diagram, diagram, wow, wow, wow. Diagram, oh diagram. No, I'm hiding it. What was it? It was -6 and -10. Okay. Right, on to the next page we go. Okay, the next question says, calculate the area of quadrilateral ABCD. ABCD. Oh, so not the trapezium. Let's just highlight this for our CLs. A, B, C, D. Okay. So how shall we do this? How shall we do this? Is there any chance that this is a parallelogram? Is there? Okay, so maybe before I go down that train of thought, the first thing that comes to mind, the first possible approach that comes to mind for me is, okay, we know that this is a trapezium, whose area we can work out by saying half the sum of the parallel sides, their lengths, times the perpendicular height. So it's kind of looking like this is the perpendicular height. We just have to check that, you know, these lines are indeed perpendicular. Otherwise, we could try to find, you know, the equation of a perpendicular line to the trapezium, well, to the one side of the trapezium. Anyway, so we can work out the area of the trapezium, is what I'm trying to get at, and then minus the area of this triangle over here. If this is a parallelogram, then we can use the area formula for a parallelogram instead, which says you just say base, the length of the base times the perpendicular height. Another alternative is to work out the area of this triangle and the area of this triangle. Honestly, maybe that's the least obscure. So I'm inclining to go that way, honestly. Yeah, I think I'm going to work out the area of triangle OCD and the area of triangle ODA. And we don't even need these to be right angled triangles. It's kind of looking like they're not. We can just use trig, right? So we know that we can use a half AB sine C type of situation. And we could, how can we do this? So we know that, okay, so I'm trying to figure out how we can find this angle or this angle or this angle for the first triangle's area, and then likewise for the other triangle's area. So for this, yay, we need to zoom in now because we're going to a tiny place. So for this angle, for example, right? No, I was about to lie. Let's see. Choop, choop, choop. Parallel lines. I was hoping to use angle of inclination in somewhere, somehow. Surely. It's not giving though. Because if I find this angle, for example, then it tells me about this angle. Not really helpful. This triangle idea, it's making me wonder now. Let's just see if this is a parallelogram. So we know that these two sides are parallel. We've been told that. So now the question is, are these two sides parallel? If they are, then ladies and gentlemen, we have got a parallelogram on our hands. So let's work out the gradient of BC, this line. So that's going to be, it's not really looking like it's going to be parallel here, but anyway, faith, hope, and love. A half minus 10, and then 0 minus 6. Oh, look at how clever this little calculator is. So the gradient here is 1,75, and then let's work out the gradient of this guy. So that's going to be 3 minus -7 over 5 minus 0, which is 2. So no, they are not parallel, so never mind that idea. Okay, so then it's kind of maybe back to the triangles idea. Nope, not feeling it. So I think I'm going to go with the original plan. Area of the trapezium minus area of this triangle. I'm hoping that this is right angled. Oh, fingers crossed, fingers crossed. Okay, so how can we check whether it's right angled? We're going to need the gradient of this line. And if the gradient of this line is the negated reciprocal of this gradient over here, a half. So in other words, if the gradient here is -2/1 or just -2, then we know that these two lines are perpendicular. And this is a 90-degree, and then our lives are great. Let's see. So the gradient of AE, that's what we're working out now. 3 minus -4 divided by 5 minus 6. The gradient, ladies and gentlemen, is -7. Oh my goodness. So this is not a 90-degree at all, remotely. So no. So then the next best thing is to figure out the perpendicular height of this trapezium, which will also then be the perpendicular height of this triangle, and then we can do the area things. So let's do that. So like I said, we know that, so let's just call it a nice name. Let H be we'll call it the perpendicular height of the trapezium A, B, C, E. Okay, so we know that the gradient of H will be equal to negative 2 over 1, which is equal to negative 2, right? So then the equation of H will be y is equal to negative 2x plus c. Honestly, I'm not sure yet why I'm doing what I'm doing, but forward we go. So I need this to be, so H needs to be a line that is perpendicular to this guy. So it's going to be a line that is something like this, and it has to go through A. So it's going to be an external perpendicular height. So let me just draw that in for myself as I figure my life out. Okay, I don't know what's going on there. Honestly, my negative 7 answer is just making me feel very weird also, but anyway. Okay. So this, I'm trying to find the equation of this line. Why do I need to find it? Well, once I find it, I am then going to figure out where it intersects with this line so that I can figure out the length of H, right, the perpendicular height, and then from there I can work out the area of this triangle and the trapezium, and then I can do my difference thing. Okay, cool. So that's the plan. So sub in the point A because it lies on the line that H is part of. So we know that, okay, when x is equal to 5, y is equal to 3. So minus 10 plus c is equal to 3. And so c is 3 plus 10, which is 13. So the equation is, whoopsie, the equation is y is equal to minus 2x plus 13. Okay. Right. So that is the equation of the line that the perpendicular height is on. Okay, so now I want to figure out, okay, where does this line intersect with this line so that I can find this point, right, this point of intersection, which I can then use to find the height. What is the actual height, the perpendicular height h of the trapezium and of this triangle that I'm interested in? Okay, so intersection, I'm just going to say intersection as if I know what that one, Yeah, when I open this in 2 years time, I'm going to be so confused. But anyway, so half x minus 7, where is that equal to this guy? Get all my x's on one side, get all my constants on the other, and we now have 2.5x, or 5 over 2x is equal to 20 times by 2 over 5 on both sides. So that is going to be 8. Right, so the x coordinate is 8. Let's figure out the y coordinate. So the y coordinate will be y is equal to a half of 8 minus 7, which is 4 minus 7, which is minus 3. And we can just do a sanity check to see if the same is true in the other equation. It should be. So minus 2 times 8 plus 13 is minus 16 plus 13, which is minus 3. So that looks good. So the point of intersection happens, well, the point of intersection is at 8 minus 3, right? So that is this cute little point over here. This is looking so shady, isn't it? Hey. Yeah, this is where they are telling, they really are driving the point home that this thing is not drawn to scale. I'm not fully comfortable. I am definitely feeling like I've made a mistake. Oh, but let's just go with it. Okay, I'm just going to check my answer so far because it's going to be so painful if I've made a silly mistake already, and then I'm just going to carry it through all the way to the end. Okay, so the gradient looks right, the equation looks right, my C looks right. Okay, that's fine. We seem to still be on the right point, on the right track, the right point. Okay, so now I'm going to calculate the length of H, okay, which is just that perpendicular height, and then I'm going to calculate the length of BA and the length of CE, which are my two parallel sides of the trapezium, and then I'll be able to get the area of the trapezium. And then I'm going to calculate the length of this triangle's base. I will already have the perpendicular height from my previous calculation, and then I'll be able to get the area of this triangle. Okay, so let's do that. Spoiler alert, I have gotten a glimpse of of the memo's workings for this question, and I am definitely taking a very long route, but yeah, we'll see how they went about it. What is happening? There we go. That's all I want. Okay, so let us erase all of this stuff. Okay. Right, so firstly we're going to work out the length of H, which is our perpendicular height. So that's going to be the difference between the y coordinates squared, well, the x coordinates squared, and the difference between the y coordinates squared. So let's just do some quick mental maths. 8 minus 5 is 3, squared is 9, minus 3 is minus 6, squared is 36. So we've got 9 plus 36, which is 45. Then let's work out the length of AB. Okay, so similar calculation. The difference between the x's squared and the difference between the y's squared. Let's try to do that in our heads too. So 5 minus 0 squared is 25. 3 minus a half is 2.5. Squared is, so that's 25 over 4. So 25 plus 25 over 4. 25 is the same as 100 over 4, so that will be 125 over 4, I think. Right, so this is 25. 2.5 squared. If we just do FOIL. Okay, so that's going to be 4 plus 1 plus 1 plus the quarter. So that's 6.25. So that adds up to 31.25. Let's see, what is this? 4 goes into 12 3 times, and then into 5 once, remainder 1. Okay, cool. So that looks good. Okay. Then the length of CE is 6 minus 6 squared plus minus 4 minus 10 squared. So 6 minus 6 is 12 squared, and here we have minus 4 plus 10, which is 6 squared. So that's 144 plus 36. So that will be 180. Well, the square root of it. Okay, so I have enough information now to work out the area of the trapezium. The trapezium ABCE. So the area of a trapezium is half of the sum of the two parallel sides, their lengths. Yep, I'm not going to try and do that in my brains. So half times the square root of 125 over 4 plus the square root of 180. Do you not have a nice representation of that number for me? Come on now. Oh yes, you do. Love it. Love to see it. Okay, so it is 17 root 5 over 4. Okay, so that's the area of the trapezium. Oh no, I forgot to times by the perpendicular height. Oh, the perpendicular height was, oh my gosh, this thing is just going to keep dancing around. The square root of 45. Oopsie. So, okay, so it is not going to be this, my friend. Instead, 255 over 4. Okay, there we go. 255 over 4 square units. Let's just double check that. Yes. Okay, and then now we want to work out the area of the triangle. So, let's duplicate this page. Just leave that there because we're going to need it. Oh, don't take away some of my calculation, you greedy eraser. Okay, so we don't really need the calculation anymore. We just want the result. Huh? Two equal signs. We shall merge them. Right. So now we want to work out the area of this triangle here, who shares a perpendicular height with the trapezium, which we've worked out to be square root of 45. So we just want the base that is perpendicular to that height, right? So we're working out the length of ED. Similar idea, similar formula, well, same formula. So that I'm going to do the difference between the y's and then the difference between the x's, And okay, so minus 3 minus 7 minus 3 plus 7 is 4, squared is 16. My second term becomes 36. So 16 plus 36 is 52. And so the area of triangle ADE is equal to half base times the perpendicular height. And let's see what that comes to. So that comes to 3 root 65. Don't lie, it's giving me heebie-jeebies. Heebie-jeebies. Okay, and then one more duplication, please. My goodness, it's getting tiresome. But okay, guys, don't discount your solution just because it's unnecessarily long, okay? As long as it's making sense to you, it is probably a very valid solution. Okay, so we now know the area of the triangle. We also know the area. Ooh. Come on, can I not copy this? Okay, I'm hoping I can still paste it. Right. All this for the love of not rewriting, for the love of laziness. Love me some laziness, man. Okay, so we now have area of this trapezium and area of this triangle. So to get the area of this quadrilateral, we'll just minus the true of A, B, C, D will be this minus this, which is going to give us oh, I was so nervous about that negative number. Like, hi, guys, why are we getting negative areas now? So to 2 decimal places, that will be 39,56 units squared. I will be so chuffed if this is right. There's such a bad feeling about it. Anyway, right, next up, let's get our picture. I've got the eye of a tiger, dancing through the fire. I am a champion. You're gonna hear me roar, louder than a lion. Okay, so the next question says, if point K is the reflection of E in the y-axis. Let me just get rid of this perpendicular height that is just unnecessarily confusing. Oh, how do I get rid of you, you little dot? I don't think I can, guys. I'm gonna try my best, but it ain't good enough. I think we just need to make peace with the dot. Oops. Okay, whatever. Right, so it's really bothering me, but we just got to be strong, guys. We just got to be strong. So we are reflecting the point E in the y-axis. So write down the coordinates of K. Okay, so we are reflecting in the y-axis. Okay, so our E is going from here. Okay, maybe let's use a ruler instead of being sloppy. Don't be sloppy, kids. Power movement. So it's gonna be like, I don't know, somewhere there or something. Okay, right, so that is where, that's the K whose coordinates we're looking for. Right, and we know that if we reflect in the y-axis, the y coordinate stays the same, right? It hasn't moved up or down. All that has happened is it's moved across. And so the coordinates of K will now be -6, -4. Okay, and then, wait a minute, we need our picture again. So the question says, okay, so using the same K that we constructed in the previous question, so coordinates are -6 and -4, we are then asked to calculate the perimeter of KEC. KEC. Okay, so that's nice and easy because we're just using the distance formula, right? Perimeter is just add up all the sides of the shape, the lengths of the sides of the shape. So this one is easy to work out because it's a perfectly horizontal line. So we can see that the distance here is 12, 6 units to the y-axis and then another 6 units to get to E. These are the ones we're going to need to use the distance formula. Oh no, actually, this one, this guy, A, okay, so that means my drawing is off. But this x coordinate is the same as this one, meaning that K is vertically above C. It's perfectly right above it. And in fact, it's 6 units up from it. And then the only one we're going to need to use the distance formula for is this one. This is the only one that's actually slanted. And we have this distance. We worked it out, didn't we? CE. Yes, we did. We worked it out over here. Lucky us. Okay. So we know that the length CE is square root of 180. We know that the length KC is 6 units, right? C is directly below, well, let's not say directly because that's a bit of a weird word maybe, is vertically below K. And then we can also see that KE is 12 units. K and E are on the same horizontal line. And of course you could have still used the distance formula. Just gotta take the shortcuts when you can take a shortcut. Okay, so the perimeter of triangle KEC will be the sum of these three. I just want to double check this length CE. Who knows, guys? Let's just do it on the calculator. I am not completely content with all these thirds showing up, so it doesn't hurt to double check, especially if you've been doing these mental maths what's. Sometimes they let us down. Okay, 6 root 5 6 root 5. What is 6 root 5? Yeah, that is the square root of 180. So we were right, we were right. Okay, so it's the sum of these guys. So that is going to be plus 6 plus 12. Whoa, wrong place. 6 times root 5 plus 3. That's just a fancy way of saying 18 plus 6 root 5. Right, so that would be the perimeter of the triangle. Okay, and then I think this is the last one. Almost there, guys. Almost there. Let's just get the diagram one more time. And we are asked, okay, so we're still continuing with K, this point that we constructed here. Calculate the size of KCE. So since we have the length of all the sides, it's giving trig, you know, cosine rule came to mind immediately, because when you have the length of the all three sides, then you can use the cosine rule to find the size of any of the angles. And then I also remember that, hey, wait a minute, this is a vertical line, this is a horizontal line, so that means these two are perpendicular. So that means we've got a right angled triangle, so we could actually even use SOH CAH TOA instead of using the cosine rule. So we can say, wait a minute, KE is perpendicular to KC, and that is because KE is parallel to the x-axis and KC is parallel to the y-axis. So in other words, KE is a horizontal line, KC is a vertical line. Right, and so therefore, what are we looking for? KCE. Let's just do that in another color. This is the angle we're interested in. We can use any of the sides that we know. I'm going to use the ones with the whole number length. So this we know is 6 units, and KE we know is 12 units, right? So, and this we just said is a 90 degree. So which ratio would we use? Well, this is our hypotenuse, and this is our opposite, this is our adjacent. So that would be tan, opposite, adjacent. So tan of KCE is equal to KE over KC, which is 12 over 6, which is 2. And so KCE will be equal to the inverse of tan of 2. And remember, tan is only positive for first quadrant angles and third quadrant angles. Only first quadrant angles are relevant here because third quadrant angles are reflex angles. You can't have a reflex angle inside a triangle. So that's why we're not doing any, you know, plus 180, minus 180. No. It's not that kind of party. Okay, so definitely need my calculator for this one. That is about 63,4 degrees. Yeah. So yeah, if you hadn't spotted that this is a 90-degree angle, not all is lost. You could have then just used your cosine rule and you should get the same answer. And that's the end of the question. Lots of weird looking answers. I'm hoping that, yeah, I didn't go astray too much, if at all. Let's see what the memo has to say. Da memo is on fire. Okay, right. So 3.1 was indeed just a straightforward application of the gradient formula, and we did indeed get a half. Perfect. Second question, we needed to find the equation of the straight line CE, and let's see what the memo had to say about that. So they start out by saying indeed the gradient of CE is a half because it's parallel to AB, and then they substituted the point E to figure out the value of C, the y-intercept, And our final answer is the same. Y is equal to a half x minus 7. Cool. Then the next question, we needed to find the coordinates of C, and they did indeed use the midpoint formula to determine that. So we got C minus 6 minus 10. Awesome stuff. Then now things started getting weird. It does comfort me a bit that this is a 4-mark question, but yeah, their answer is so much more straightforward. Let's see what they did. So they worked out the area of BCD. The area of BCD. They said half of 7.5 times 6. Where do you get 7.5? Where do you get it? So this is the 7.5, because D is 0 and 7, and this little bit OB is a half unit, so that's 7.5. And then okay. Right, so all that they did was they constructed the perpendicular height over here. You see now, right? Because I don't know why I'm not just allergic to using the ruler. So this would be the base. They chose this base for this triangle BCD, like I said. They chose this base, and then the perpendicular height would be a line that is parallel to the x-axis, because the base is on the y-axis. So the perpendicular height would be this guy, right? And that distance over there is 6 units, because the coordinates of C are minus 6 minus 10. So the base 7.5, the perpendicular height 6 units. And then let's see, similar then for this triangle, BAD, we have the base being 7.5 units, and then this time the perpendicular height would be from A to the y-axis. Right, so this is the base, 7.5 units, and what is the perpendicular height? Now the perpendicular height would be 5 units, right? To go from the y-axis to A is 5 units. So then it's half of 7.5 times this perpendicular height, right? And then they add them together to get 41.25. I don't think I got that. Oh, did I? Did I? Oh! 255 divided by 4 is not 41.25. Oh my gosh. Where did I go wrong? Okay, so like I promised, my endeavor whenever I do get a question wrong is to see, okay, what did I mess up? So let's see if we can get an educational moment out of this. This was a very long working, so buckle up, kids, buckle up. Okay, I'm not going to be able to erase everything. Right, okay, so we started out by saying that H is going to be the perpendicular height of the trapezium ABCE. So this little blue line over here. So then I wanted to find the equation of the line that H lies on. So we started by saying, okay, the gradient of that line will be the negated reciprocal of this number, this gradient here. So that would be minus 2 over 1, which is minus 2. So then the equation that H lies on, the equation of the line that H lies on, would be y is equal to minus 2x plus c. And then I subbed in the point A, because I wanted to, this perpendicular height is a line that goes through A. So then I put in minus 2 times 5 plus c must give me 3. So then that means minus 10 plus c is equal to 3. So c is equal to 3 plus 10, which is 13. So then the equation of this line is y is equal to minus 2x plus 13. Okay, happy with that so far. Next, I wanted to find what is the intersection between this line and this base over here. Whose equation is that? So then we worked out, okay, half x minus 7, where does it intersect with minus 2x plus 13? Got all my x's on one side, my constants on the other. 13 plus 7 is 20. Over here I've got 2.5x. And then to get x by itself, I times by 2 over 5 on both sides. 20 times 2 over 5, so that's 40 over 5, which is 8. So my x coordinate is 8. And then to figure out the y coordinate, I put it into the equation y is equal to a half x minus 7. So 4 minus 7 is minus 3. I even tested and put it into the other equation. Minus 2 times 8 minus 16 plus 13 does also give me minus 3. So that confirmed for me that the point of intersection between the perpendicular height and the other side of the trapezium, the other parallel side of the trapezium, is 8 and minus 3. Okay, great. So now I then proceeded to work out, okay, what is the length of h then, this perpendicular height of the trapezium? So that was 8 minus 5 squared, and then minus 3 squared. Okay, so that was, let's just use our calculator now to be super safe. So 8 minus 5 squared plus minus 3 squared. So that was 3 root 5. And that is the same as 45, because remember 45 is the same as 9 times 5. So that's where the 3 is coming from. The square root of 9 is 3. Okay, so that looks good. And then the next thing we wanted to calculate was the length of each of the parallel sides of the trapezium. So for AB, it was going to be the square root of, let's do the difference between the y's, and then the difference between, the difference between the y's, and then the difference between the x's. Oh, I think I'm outside now. Okay, so that's 5 root 5 over 2. That kind of looks right to me. 5 root 5 is the same as square root of 25 times 5, which is square root of 125. And then at the bottom would be 2, which is the square root of 4. So that is square root of, we can just confirm this as well. Square root of 125, 125 over 4 is the same as 5 root 5 over 2. Cool. And then the last one was the length of CE. So that was going to be 6 minus 6 plus minus 4 minus 10 squared. So that is 6 root 5. And we just want to confirm that the square root of 180 is indeed the same. Yes, it is 6 root 5. So then the area of the trapezium would be a half times the sum of the parallel sides. So that is root 45 plus root 125 over 4 times the perpendicular height. Oh, I might have added the wrong things. It's not, it's root 180, right? And the 125 over 4, those are the two parallel sides, yes. And then we're timesing by, oh no, I added the right things. This is where it helps to have your workings written down. Okay, so 255 over 4 is indeed correct. Right, so now to work out the area of the triangle, it shares the same perpendicular height, root 45. Was it? Yes, root 45. Okay, and then we needed to work out the length of DE, which we did by saying, I didn't use E, I used the confusing point. Okay, so that was my mistake. Right, so it shouldn't be minus 3 minus 7, it should be minus 4 minus 7, minus 4 minus 7. Oh, should probably have written down the coordinates of D. Right, the 8 and minus 3 it's to do with the perpendicular height. When we calculate the area of the triangle, we're saying the length of the base, and the base is ED, so we calculate from the distance from E to D, not from this funny point outside. Okay, so that was my mistake, and then I got it right for the x coordinates. What an unfortunate mistake. So let's just do it mentally. So minus 4 minus 7, minus 4 plus 7 is 9, and then minus 4 plus 7 is 3, squared is 9. 6 minus 0 squared, so that's 6 squared, which is 36. So we've got 36 plus 9, which is 45. Oh. Right, so this ends up being root 45 times root 45 is just 45, and half of that. Okay, so now to work out the area of the weird little shape, this is now 45 over 2, so we might, oopsie. Okay, that looks more wholesome. Hey guys, I did say, right? These examiners do try their best to give you nice numbers to work with, but that's not to say that you must delete your workings if you end up with a weird irrational number. Sometimes the numbers just be irrational, guys. Sometimes they just be irrational. Okay, so this is 165 over 4, which is indeed 41.25. Okay, happy me. But yeah, also, yeah, their solution is a lot more elegant, a lot nicer. Definitely recommended. Okay, next question. K being a reflection of E in the y-axis, we both get minus 6 and minus 4 as our answer. And then the next question was the perimeter of KEC. So for that, we did use the distance formula. They actually use Pythagoras. Well, I mean, Pythagoras and distance formula are really same WhatsApp group. And they don't give up the answer in set form, sort of. So that's also my mistake. I don't know if it's a mistake per se, but yeah. I think third form is nice when you have like a nice third, like 3 root 2, not when it's like a sum of 2 terms. Maybe the rule of thumb is your answer must always be 1 term. I don't know. So let's just work out 18 plus 6 root 5. So that is indeed about 31,42 units. Okay, righty. And then the last question, we needed to work out the size of angle KCE. So they used tan as well as their first option, and the answer is 63,43 degrees. They've rounded to 2 decimal places. I guess that was the rule of the paper, my bad. And of course you can use any of the other ratios. You can use sine. Well, not any of the other ones. You'd have to work out. Well, yeah, you have the length of all the sides in the triangle, so you could use sine or cos. The alternative that they do is something to do with the angle of inclination. I'm not sure. I really want to know. And then the last option is to use the cosine rule. Yeah, so that's question 3. Very bombastic. Feeling a bit like a baptism of fire back into my recording routine. But anyway, I hope that the video has been helpful. and I will catch you another time for another chat.